Good morning. This is Mrs. Rondeau. We're going to be talking about something called angle-angle similarity with triangles. Our essential question today: how can you show that two triangles are similar? Our learning goal: I can prove two triangles are similar using angle-angle criteria. And this set of notes, you can just type into the Google Doc. I do understand that it would be difficult to mark the diagrams that way, but I will not be marking you down for that in your Google Doc today. Or if you prefer, maybe slightly better version of notes would be using Cami. So feel free to use whatever style you would like. Here we go. So first off, we have the angle-angle similarity theorem for triangles. And let me just get my pen going here. Okay, so this symbol right here, the little tilde, this is means similar. In this case, similarity. So angle-angle similarity theorem for triangles, that is the abbreviated way to write it. But essentially, it's actually angle-angle-angle similarity. And we shorten it to only two, and here's why. If I go to my picture, basically the idea is if I know that angle A is congruent to angle X, and I know, for example, angle B is congruent to angle Z, then because of the triangle sum theorem that says all the angles in a triangle add up to 180, then angle C and angle Z would have to be congruent because of triangle sum. And so let me give you a quick example. If angle A, for example, is 50, and then angle X is also 50. If angle B is 30, then angle Z is also 30. So when I go to do triangle sum, I would say, oh, I have 50 and I have 30, and I'm going to add them up. That gives me 80. And then I'll subtract that from the total, which is 180 for a triangle, and I get 100. This math is the same for both triangles, meaning our leftover angle would have to be the same in both triangles. Now, granted, those numbers don't exactly make sense for that picture, but hopefully that helps you to see how if you know two angles in a triangle, you actually know all three, or you would find it very quickly. So it is actually angle-angle-angle, which was not a theorem for congruence, but is a theorem for similarity. But you'll see in the similarity world, we only use two A's, angle-angle, because we don't want to go through and do the math to find the third angle every time. So we say two is enough. That's it. All right, so I'm going to go ahead and go forward here. If I can figure out how to tell myself to do that. There we go. All right, so some of these examples are in the textbook, so you're welcome to grab them there. We're going to find the length of BE if possible. We are also going to be using some colors today: purple, blue, orange, and red, because we're going to get to do the love connection. All right, so starting off with finding the length of BE. So I'm supposed to somehow magically find this length right here. And so the way that we're going to approach these problems today is really looking at if the triangles are similar, then we know the sides are proportional, meaning we can write two fractions with an equal sign, a proportion. So I would need to know, in order to say these triangles are similar, I need to know that at least two angles match up. And there should be one like right off the bat that you go, oh my gosh, look, there's vertical angles. So right off the bat, there's one set of angles. But then you'll notice we have these little arrows here that stand for parallel lines. So those two lines are parallel. And if I pretend for a minute that this line goes all the way, continues further through, that would be a transversal. That's a horrible looking transversal. But that would be our transversal that cuts through the parallel lines. And then going one step further, so we have parallel lines, we have line CE that cuts through them. Then I can say that this angle here is congruent to this angle here, which may seem like a stretch, but it actually has to do with the parallel lines. That's one of our angle pairs coming back all the way from last semester. And so really quickly, I'm going to highlight this. Actually, so I'm going to use yellow for a minute. I apologize, I didn't say yellow. All right, so if I highlight my parallel line with my transversal with my parallel line down here. Hopefully you see there somewhere in the midst there that what I highlighted is a Z for alternate interior angles. So this is my favorite angle pair for parallel lines called alternate interior angles. So those two angles would match up. Now I have marked two angles in my picture. So that's enough information to say, hey, guess what? Triangle, I'm going to say BCA. So I did one mark, two marks, or two arcs. So one arc, two arcs, and no arcs is similar to triangle. And I'm going to match up that same ordering system for my letters here. So I did 1, 2, and none. So B, E, D. So once I say the triangles are similar, one of the things we learned last time is that their sides are proportional, meaning I can match them up. So here goes with matching up the sides. I'm going to start with blue. And I'm going to say, okay, I can match up side BC right here with, let's see, BC would match with BE. So that would be this side right over here that I kind of highlighted. Oh, perfect. All right. And I said before that I like to do small to big. So in this case, it looks like my smaller triangle is the one on the left. So I would say 54 over X. I'm going to throw in my equal sign. And then I'm going to do the other way. So I'm going to grab orange. And I'm looking at AB. So let's see. AB would match up with DB. So DB down here. And again, I did small to big, so I'm going to do small to big. And I'm going to need a calculator to help me out. Oh my goodness gracious. Actually, I can just pop it into a calculator. That's totally fine. But since I don't want to have to use a calculator, I do have another option. I can reduce. So I'm just going to actually start by rewriting this. 54 over X equals, this fraction is reducible. I can divide top and bottom by 9. And there might be something bigger, but at least 9. And when I do that, I get 4 over 6. That's a whole lot nicer. I could do it again if I want. Yes, that's true. Or I could immediately start cross multiplying. So I'm going to divide by 2, top and bottom. So I'm just reducing my fraction here, making the numbers a bit smaller. That looks a lot easier to work with. Then I'm going to go ahead and cross multiply, do the love connection, draw that pretty heart. Okay, so I do X times 2 and bring it down is 2X. 3 times 54, that's not one I know off the top of my head. Let's see, 3 times 4 is 12, 2 carry the 1, 162, I believe. I'll double check that for us. So once I have that, then I should be ready to solve. Ooh, I got it right, 162. Then I would divide both sides by 2. And I get X equals 81. And double check that I answered the question. My X represented my BE. So yes, I did answer the question. If I wanted to make it super clear, I could say BE equals 81. And we don't have any units here, so I would leave no units. All right, on to the next one. Find the length of RT if possible. So again, we keep seeing this if possible. That is because it's possible maybe we don't have similar triangles or congruent triangles or any way to do it. So before we can jump in and write a proportion, we need similar triangles. They happen to mark for us this angle right here that matches up. And there is one other angle that matches up. They didn't mark for us, but you are expected to know. And that is an angle that the triangles share. Up here at the top, we would call this a reflexive property because it's the same angle, whether you're talking about the small triangle or the big triangle, and that's this angle right here. Both triangles, the small one and the big one, have angle R. So that gives us our angle similarity. So I can say triangle. I'm going to go RSV, that's the small triangle, is similar to triangle RTU. And so once I say my triangles are similar, then I know the corresponding sides are proportional. So I can create my proportional business here. Now, in order to do this, I need to set up a proportion. I'm going to match up my sides here. I'm supposed to be finding RT. So I'm going to start with blue, and I'm going to make just a mark here that I want R to T. That's the thing I want, so I'm going to call it X. And so RT would match up with RS. And like I said, I like to do small to big, so I'm going to do 10 over X. But it is totally your choice. You could do it the other way if you want. And then I'm going to switch colors and match it up. And so I would match up 8 and 12, and 8 is from the smaller triangle, so I would do 8 over 12. I could once again reduce here like I did last time. This time I think I can handle just dealing with the numbers as they are, so I'm going to go ahead and cross multiply. Do the love connection. Heart's a little lopsided there. All right, so X times 8 and bring it down is 8X. 12 times 10 gives me 120. Then I would need to divide both sides by 8. And let's see what I get. 8 goes into 12. 1 through 4 left over. Looks like 15. And again, they didn't give me any units, so I'm just going to leave it without units. If I wanted to be slightly more clear, I could specifically, to answer the question, say, oh yeah, RT is 15. It's not really a necessary step because we labeled RT as X, but if you wanted to, you could. On to the next one. A builder was given a design plan for a triangular roof as shown. Explain how he knows that triangle AED is similar to ACB, then find AB. So how do we know the triangles are similar? All right, so we're going to jump right in. I see these arrows. Remember, that means parallel lines. And with parallel lines, there's some special relationships for angle pairs. Specifically, if I look at this line right here, A to C for a minute, that would act as a transversal, as if my parallel lines kept going. And so with that, I could actually say this angle is congruent to this one. So the angle at E and the angle at C are congruent. The reason would be, so I would say angle C is congruent. Actually, I can't say angle C, I apologize. I can say angle C, it's angle E that I can't say because it's not specific enough. So angle AED is congruent to angle C because they are corresponding angles. And that is corresponding angles. So C and A for corresponding and angles are congruent. So that's from a long time ago. And then in the same way, so I'm going to erase some of my work here. Okay. In the same way, on the other side of the triangle, we have what I might call a different transversal over here. And again, if my parallel lines continued, then hopefully you can see this angle would match up with this one for the same reason. So I could say angle ADE is congruent to angle B because they are corresponding angles, like so. And I did that all in blue, but I'm going to switch it back I'm going to erase all that and do it in purple. So I apologize if you did it in blue already, just because I want to use blue for my side. So I'm just going to put it back into purple. Okay, so it was this angle is congruent to this one, and that was angle ADE is congruent to angle B because they are corresponding angles. Once we have two pairs of angles, then we can say the triangles are congruent. We already have the statement up there, so I'm cheating and just saying the triangles are similar by angle similarity. And then I said I was cheating because I didn't write out the name of the triangle, but we have that statement up at the top. All right, so we were supposed to explain how we know. That's how we know. Then I need to find AB. So I'm going to grab my blue here and get started marking some signs. I want AB. So I'm going to go ahead and mark that off right away. This is what I want is AB. I'm going to call that X. AB matches up with AD. And again, I'm going to go small to big. So 6 over X. And then equals. And I'm going to grab from my other side of the triangle here. Let's see, 9 and 15 would match up. And that would in fact be 9 over 15. And again, you can reduce if you would like. I'm just going to go ahead and go for it. I'm going to cross multiply, do the love connection. Those arrows look a little bit ridiculous. See if I can make them look a little prettier. All right, so cross multiply, I'm going to start with the x, the first denominator, multiply it by 9 and bring it down. I get 9x. Then I'm going to do the 6 times 15, and I get 90. Then divide both sides by 9, and I get x equals 10. And again, if you want to be more specific and go back and say AB equals 10, that's fine. This time we do have feet, so actually I'm going to go ahead and model that because we didn't have units before. So I would say AB equals 10 feet. So you want to make sure and include units if we can. All right, here's our last one. Find PQ if possible. So this one's a little bit weird because what we're trying to find is P to Q. So I'm going to leave that for a minute and not find PQ. Actually, well, yeah, I'm not going to find PQ just yet. First, we got to see if it's possible. So if I look at my triangles, I see a matching angle that they gave us, and I see a right angle on the left, which means there's a right angle on the right. They do, in fact, have 2 matching angles, so I can say the triangles are similar. So let me see if I can write that a little bit nicer. Let's start with triangle. Oh, dear heavens. Okay. Triangle TSQ would be not congruent. Sorry. Similar to triangle. Let's see, I did the one arc, so that would be P. The right angle would be S, and then the other angle R. So PSR. All right, so in this one, I'm actually going to start by trying to match up the sides that I can match up. It's a little bit weird. I'm going to start with blue, and I go to my first triangle to the small triangle, and I'm going to do this long leg. So it's a side that is adjacent or touching that right angle, but it's the long one. If I match that up on my other triangle, so I'm building my first ratio, small, and I want to compare it to the big. The big that I'm comparing it to is this piece right here, which I'm just kind of doing over to the side, P to S. So that's the piece I'm going to compare it to, which is a little weird because it's like this whole side right here. And it's just hard to see because we have lots of stuff going on. So that side right there. Okay, I might actually take this out. Let's see if we can do it without this. Okay. All right, so that length, I don't have a measurement for it. I know part of it is 9, but I'm missing the P to Q, which is what I'm trying to find. So I'm going to call that P to Q X. Then if I want the whole piece, that whole distance, if you recall, would this whole thing here, we talked about this on a different problem, I could call that whole length 9 plus X or X plus 9. We probably like X plus 9 better. I'm going to do that. X plus 9, because if I add those two pieces together, that will give me the whole length. So I'm going to say X plus 9. And so that's what I'm going to put in my problem for the entire length there. Then I do an equal sign. And then I'm trying to match it up. Last thing to match up here. Let's see if I can match up. Then if I go back to my small triangle, the short side is, oopsie, sorry about that, right here. This piece right here, which is 9. That's the short side. That matches up with over here, my short side, which is 12. Okay, so I would say 9 over 12. This time I might actually reduce because I have some big numbers in there. So I'm going to rewrite, I have 15 over X plus 9. On this side, I can divide top and bottom by 3. So I get 3/4. That's a little bit nicer. And then cross multiply. do the love connection. And when I do that here, my first denominator has a plus sign, so I'm going to put in parentheses and multiply x plus 9 times 3. So I'm going to do 3 times x plus 9. And then I go to my second denominator and cross multiply. 4 times 15 is going to give me 60. Then distribute. I get 3x plus 27. I'm going to subtract that 27 from both sides. And it looks like I get 33 equals 3x. This cancels to 0. And then divide both sides by 3, and I get x equals 11. I'm going to go back and make sure that that's what I was looking for. When I go back, my x was labeled as PQ, so I'm good to go. Again, if I want to make that statement super clear, I could say PQ is 11, the distance from P to Q. And this time we don't have units, and that's it. I hope you guys have a great day. Make sure to get those turned in, and we'll see you next time.